Continuing from the previous video, we're now going to sketch a graph of the following functions by transformations. Now, the book uses the letter A. I don't want to use the letter A. I want to use the letter B because we have used A before in transformations, and we're about to do that right now. So I don't want to get you confused. So from here on out, please assume that the base will be the letter B, not the letter A. Okay, so doing our transformations, we have three letters. We have H, we have A, K. So that's the A I didn't want you to confuse with. H is always with the variable. I'm going to write down here, our generic form of a transformation is A times the function of X minus plus K. So H is what you are subtracting from the variable. Here we have X plus 1. Well, X plus 1 can be rewritten as X minus negative 1. Since we're subtracting negative 1, that means H is negative 1. Since H is negative, this says to move left 1. A is what you multiply the function by. We are multiplying the function by negative 2. This will do two things. The negative creates a vertical reflection, and to be specific, a vertical reflection over the x-axis, and the 2 creates a vertical stretch. Now, if you want, to me, it's a little bit easier if we play with numbers. A will directly affect the y coordinate. So we could have also said multiply the y coordinate by negative 2, which I think is much easier to do when we go to do these transformations. K will also directly affect the y coordinate. K is what you add to the function. We're adding 5, so K is 5. So we could say up 5. Or we could say add 5 to the y coordinate. Either one is completely fine. So H inversely affects the x coordinate. It looks like you're adding 1 to the variable, but you actually subtract 1 to go left. A and K directly affect the y coordinate. Now our non-transform function here, I'm going to do it in a different color, is y equals 4 to the x. Because that's y equals 4 to the x, and I'm a little freaking out now because this is not going to fit on our graph. I did not plan this very well. Let me think about it. Do. We might have to change some numbers. Ba-da-ba. Let's see what happens. Since it's 4 to the x, that means it's going to go through 0, 1. And 1, 4. Remember 0, 1 always for the non-transformed, and 1, the base again for the non-transformed. So in purple here is the base untransformed graph 4 to the x. And remember, it has an asymptote at y equals 0. So we're going to manipulate this purple graph. Okay, and what we're going to do is we're going to go through all 3 steps, H, A, K, in that order. So for example, 0, 1, we're going to move it left 1 because that's what H says to do. Puts us right there at negative 1, positive 1. We're going to multiply the y coordinate by negative 2. Then we'll be at 1, negative 2. Excuse me, negative 1, negative 2. And now we'll take that point and move up 5. So just count 1, 2, 3, 5. That ends us up at -1, 3. 0, 1 moved to -1, 3. Left 1, multiply the y coordinate by 2 for the stretch flexion, and then moved up 5. We're going to do the same thing for 1, 4. Here we go. So 1, 4, move it left 1. That puts us at 0, 4. Multiply the y coordinate by -2. Don't worry, that will put us at 0, -8. 1, 2, 6, 7, 8. Right? So we're at 0, -8. And now we're going to move that up 5, which will have us finish at 0, -3. The left 1, multiply the y coordinate by 2 and bring it up 5. Great. Our horizontal asymptote is not affected by H or A, because if you take something that's horizontal and move it left or right, it doesn't change. And since it's at y equals 0, if you multiplied the y value by -2, well, 0 times -2 is still, doesn't make a difference. But moving it up 5, we now have a new horizontal asymptote at 5. I should say y equals 5. 1, 2, way up here. Okay, now as far as the graph is concerned, we only have 2 points there. Again, we're only looking at the stuff in blue. If you have glasses that are purple tint, wear them now, because then you won't see the purple graph. But you have to imagine that we took the purple graph and flipped it. So instead of it increasing, it's now decreasing. So it's going to start close to the asymptote, like it did before, but now it's going to go down, and please forgive this graph. Oh, this is looking pretty good so far. Oh my gosh. Hooray. So in blue here is our final answer, f of x equals -. Okay, in part B, we're going to do something very similar. We have a guest appearance, and that guest appearance is we have a negative on the variable. We have not seen this before, so we'll talk about what that does. We still tend to go in our order here, but we're going to take care of this -x first. That's going to be the first step. Our first thing we're going to do is when you put a negative on the variable, this says to reflect over the y-axis. There's a letter associated with that, but I'm not going to tell you what it is because I don't want you to get confused. But I'm just telling you that's what we do first. Then we'll apply the A. A is 1/2. Because A is 1/2, this will be a vertical compression. And you could also say multiply y coordinates by 1/2. And K is 1 because that's what you're adding to the function. And as you might guess, that means up 1. If you would, please attempt to, well, I mean, you can do this part very easily. Pause the video and then attempt to graph the function. The first time I'm going to sketch what the base graph looks like, and the next time I'm going to do the whole thing. Make our lives a little bit easier. I'm going to count the x-axis by 1s. But I'm going to count the y-axis by 1/2s. I'll make it, I think, in my. So go with that technique, pause the video, and see what you can do. Without going through what I just did there, hopefully you remembered that the base graph, which in this x, goes through 0, 1, and 1 comma the base. That's where I got those 2 points from. And remember, it has a horizontal asymptote at y equals 0. Oh. Ah! Okay, so now you're going to take these purple points, 0, 1, 1 comma 3 halves. Apply the steps 1, 2, and 3 that we have outlined. So again, if you need to, pause the video again and see how you did. All right, so if we had 0, 1 and we reflected over the y-axis, does that point move? No, because it's on the y-axis, so that one doesn't change. Vertically compress by a half or multiply the y-coordinates by a half, your choice. 1 times 1/2 is 1/2, so that point got compressed down here. And now we're going to take that and move that up 1 unit, while 2 tick marks on the y-axis would be 1 unit. So 0, 1 ends up at 0, 3 halves. Do the same thing for 1, 3 halves. 1, 3 halves, we're going to reflect. Oh, what I did. Oh my gosh. Can I take the whole... Why? Why does it do this? I'm going to put you over here. And then you have to live with it. Oh no. That is so weird. Alright, nobody saw it. Okay, so we're at 1 3 halves. If that got reflected over the x-axis, that would make it -1 positive 3 halves. Multiply the y-coordinate by a half. Half of 3 halves is 3/4. So like right here. And now move that up 1, again, 2 tick marks. Boop. So that'd be 1 3/4, which is 7/4. That ordered pair is -1. I want to write a mixed fraction. No! No! Don't do it! Mixed salad's good. Mixed fraction's bad. Alright, where's the new horizontal asymptote? Hopefully you said y equals 1. Don't say 1. 1's a number. Give me the equation. Okay. This one also had a reflection, but this time it's over the y-axis, so this makes it decrease. Namely, it makes it look like a exponential decay. Not a coincidence. Exponential decay is just a reflection over the y-axis of an exponential growth. So, starting my arrowhead up high, going through the 2 points, going towards the asymptote, making this 1 point extremely large so it looks like I did it right the first time. The graph in blue is our function g.